Imagine a telescope floating in space, far above the surface of the Earth, drifting silently through the darkness. It's not just any telescope, but a sentinel on a grand mission, watching the cosmos with unwavering focus. This is the Kepler Space Telescope, a marvel of human ingenuity, launched to answer one of humanity's most profound questions. Are we alone in the universe, or do other worlds like ours exist? Kepler was designed to search for planets orbiting distant stars, far beyond the familiar boundaries of our own solar system. It became a cosmic census taker, revealing that planets are not rare at all, but are scattered throughout the galaxy in astonishing numbers. Named after the pioneering astronomer Johannes Kepler, this telescope took the search for new worlds to an entirely new level, opening up possibilities we had only dreamed of. Kepler was a technological marvel, equipped to detect the faintest signals of distant planets as they passed in front of their stars, using sensitive instruments to capture tiny dips in starlight. Before Kepler, our knowledge of planets was limited to those in our own solar system: Mercury, Venus, Earth, and the rest. We gazed up at the night sky and wondered if other stars had planets too, or if our solar system was unique. Kepler was sent to find out. Not to take beautiful pictures, but to hunt for planets by carefully measuring the light of thousands of stars. Its launch in 2009 marked a turning point in astronomy, ushering in a new era of discovery and exploration. For the first time, we had a dedicated tool in space, designed specifically to find exoplanets and expand our understanding of the universe. Kepler's mission was to map the planetary landscape of our galaxy, searching for Earth-like worlds and distant giants alike. The data it collected would forever change our perspective, helping us understand our place among the stars and fueling new questions about life beyond Earth. Kepler's journey was a leap into the unknown, a bold voyage of discovery that continues to inspire us to look up and wonder what else is out there. How did Kepler find hidden worlds? The answer lies in a blend of ingenious engineering and patient observation. A mission designed to peer deeper into the cosmos than ever before. It used a clever technique, one that transformed the way we search for planets beyond our solar system. The telescope stayed in one place, trailing Earth as we orbit the Sun, maintaining a stable vantage point far from the planet's shifting atmosphere. It fixed its gaze on a patch of sky in the constellations Cygnus and Lyra, a region chosen for its rich collection of stars. This field contained over 150,000 stars, each one a potential host to distant planets. Kepler watched these stars for years, a testament to patience and persistence, collecting a continuous stream of data night after night. It was a powerful light meter, measuring star brightness with precision, detecting even the faintest changes in light. Kepler looked for tiny dips in a star's light, like a moth blocking a street lamp, an almost imperceptible shadow cast by a planet passing in front of its star. This event, called a transit, reveals an unseen world, offering a fleeting glimpse of a planet hundreds of light years away. The dimming caused by a planet transit is incredibly small, often just a fraction of a percent. For an Earth-sized planet, the brightness drops by less than 1 part in 10,000, an astonishingly subtle signal to detect. Kepler needed a clear, unobstructed view of the stars to catch these fleeting shadows, free from the blurring effects of Earth's atmosphere. A dip in starlight had to be periodic to confirm a planet, repeating at regular intervals as the planet completed its orbit. By measuring the transit, scientists calculated the planet's size and distance from its star, unlocking clues about its composition and potential habitability. Kepler's unblinking stare turned starlight into data, and data into new worlds, expanding our understanding of the galaxy. It was a quest for knowledge, revealing the universe's hidden secrets and showing us just how many worlds might be out there. Kepler's method was simple in concept, yet required incredible precision and unwavering dedication to uncover the planets that orbit distant suns. The planets Kepler searched for are called exoplanets. These mysterious worlds have fascinated astronomers for decades, sparking curiosity about what lies beyond our own solar system. An exoplanet is a planet outside our solar system, orbiting another star. Unlike the planets we see in our night sky, exoplanets are incredibly far away, often hundreds or even thousands of light years from Earth. For most of history, we only knew our solar system's planets. Mercury, Venus, Earth, and the rest were all we could observe. And we wondered if other stars had planets too. Exoplanets were once just a theory, a dream of scientists and writers. Science fiction imagined distant worlds, but there was no proof they existed. Finding them was difficult because they don't produce their own light. They are hidden in the glare of their parent stars, making them nearly impossible to see with traditional telescopes. Kepler changed everything by making the search systematic. It stared at thousands of stars looking for tiny dips in brightness that meant a planet was passing in front. Exoplanets come in all shapes and sizes, unlike anything in our solar system. Some are giant gas worlds, others are rocky and small, and some are even stranger than we imagined. Kepler discovered hot Jupiters, super-Earths, and planets orbiting two stars. Worlds that challenged our ideas of what a planet could be. The variety of these worlds shows nature's imagination. Each new discovery reveals a different kind of planet, with unique climates, atmospheres, and possibilities. Studying exoplanets helps us understand how planets form and evolve. By comparing them, we learn about the forces that shape solar systems, including our own. It's like studying thousands of families to understand human development. Each planetary system is unique, and together they tell the story of the universe. The search for exoplanets is part of the search for life beyond Earth. We look for planets with the right conditions, liquid water, warmth, and the right atmosphere. Finding worlds with the right conditions for life focuses our search. Each discovery brings us closer to answering one of humanity's oldest questions. Each new exoplanet is a piece of the puzzle, bringing us closer to answering, are we alone? The more we find, the more we realize how vast and diverse the universe truly is. Kepler's discoveries expanded our understanding of the universe, revealing that planets are common and that the cosmos is full of possibilities waiting to be explored. Let's delve into the transit method Kepler used to find worlds. A transit is when one object passes in front of another from our view. Kepler watched for the tiny shadow of an exoplanet crossing its star. This method requires a lucky alignment of the planet's orbit. For every system Kepler detected, many more are tilted out of view. The thousands of planets Kepler found are just the tip of the iceberg. A transit creates a dip in the star's brightness, forming a light curve. The dip's depth tells us the planet's size relative to its star. The transit's duration reveals the planet's speed and star size. Multiple transits confirm a discovery, indicating an orbiting body. The time between transits gives the planet's orbital period. This helps estimate the planet's temperature and habitability. Kepler was a master at reading the shadows, revealing hidden worlds. Among Kepler's discoveries, Kepler 22b stands out. Announced in 2011, it was the first planet found in its star's habitable zone. This zone is where conditions might allow liquid water on a planet's surface. Kepler 22b orbits a star similar to our Sun, about 600 light-years away. It's a super-Earth, about 2.4 times the size of Earth. Its year is about 290 Earth days, similar to our own. The possibility of liquid water makes Kepler 22b tantalizing. If it's rocky with a stable atmosphere, it could have oceans. The discovery showed planets of the right size and orbit exist. Kepler 22b became a symbol of what we were looking for. It fueled hopes of finding a planet resembling our own. Kepler 186f was a leap forward, announced in 2014. It was the first Earth-sized planet found in another star's habitable zone. Kepler 186f is only about 10% larger than Earth, likely rocky. It orbits a red dwarf star, much cooler and dimmer than our Sun. The habitable zone is closer to the star, with a 130-day orbit. Life on Kepler 186f would be different, with redder light and larger star. Red dwarf stars are the most common in the Milky Way. If they host Earth-sized planets, the number of such worlds is vast. Kepler 186f was evidence that such worlds exist. It expanded our search for life to a new category of stars. The discovery suggested common stars might host promising worlds. Kepler 186f was a milestone in the search for habitable planets. The habitable zone, or Goldilocks zone, is where liquid water can exist. It's the orbital region around a star with the right temperature for water. Too close, water boils. Too far, it freezes. The zone's location depends on the star's size and brightness. Our sun's habitable zone includes Earth, allowing life to flourish. Being in the habitable zone isn't a guarantee of life. A planet needs the right size, atmosphere, and chemical ingredients. The habitable zone is the first filter in our search for life. Kepler's discoveries showed rocky planets in the Goldilocks zone aren't rare. This finding suggests life might be possible on billions of worlds. The stage for life might be set across the Milky Way. The next question is whether life has begun on any of those stages. The Kepler mission ended in 2018, but its legacy is monumental. It changed our view of the universe, revealing a galaxy teeming with planets. Kepler found over 2,600 confirmed exoplanets, with more candidates awaiting verification. It turned exoplanet study into a central pillar of modern astronomy. Kepler provided a fair sample of the galaxy's planetary population. The data suggests at least one planet for every star in the galaxy. Our galaxy likely has hundreds of billions of planets. Kepler's data estimates many planets might be Earth-like. There could be billions of potentially habitable worlds in the Milky Way. Kepler's legacy is in the questions it inspires. It paved the way for new planet-hunting telescopes like the James Webb Space Telescope. These telescopes will study exoplanet atmospheres for signs of life. Kepler showed us where to look, opening the door to new discoveries. The search for biosignatures can now begin in earnest. Kepler's story is one of exploration, a voyage across space and time. It revealed a universe richer and more complex than we knew. Our solar system is likely one of countless planetary systems. The search for exoplanets is a search for ourselves. Finding another planet with life would be a profound discovery. It would mean life is a common phenomenon in the cosmos. Telescopes will continue Kepler's work, mapping our galactic neighborhood. The James Webb Space Telescope is already studying exoplanet atmospheres. We may soon learn if some planets are truly habitable. We are in the golden age of exoplanet exploration. The journey Kepler started is just beginning. We look at the night sky and see suns surrounded by worlds. And we wonder,